nature of chemists to try to duplicate nature, many tried over those centuries to invent artificial or synthetic fibers. Fibers that could be mass-produced at low cost in a lab. No worry about crops and herds affected by weather and disease. No need for labor-intensive harvesting, shearing, gathering. But it wasn't until the late 1930s that someone finally succeeded. This man, Wallace Carothers, a chemist in the Wilmington, Delaware research lab of the DuPont Company. What he and his team did, we'll tell you how in a minute, was create not only the first synthetic fiber, but a revolutionary material, nylon. Strong yet elastic, like silk, only better. In fact, nylon became a huge commercial success in 1940 precisely because of its superiority over silk in making women's stockings. Nylon stockings didn't run or tear as easily as silk ones, or cost as much. American women bought 60 million pairs of nylons before the U.S. entered World War II, when all nylon production went to the war effort. The new material was strategically important. During the war, nylon was made into uniforms, tents, airplane tires, and with silk supplies from Japan cut off, military parachutes, almost 4 million of them. As for nylon stockings, until the war's end, they were famously rare. Women faked the look of stockings by drawing seams down the backs of their bare legs. Time to draw your attention back to how nylon was invented, which we'll explain using paper clips and spider webs. Wallace Carothers was fascinated by polymers, which he correctly guessed were just ordinary molecules, only longer. Here's the way generations of chemistry students have learned about polymers. Take a paper clip. One paper clip represents one molecule or part called a mer. Since the Latin word for one is mono, that's a monomer. The Latin word for many is poly, so if you link several paperclip monomers together, you get a polymer, actually a polymer chain, single units linked together into a long chain. There are many polymers in nature, most notably in terms of this story, spider silk, what makes up spider webs. In fact, spider silk is the strongest natural polymer known, stronger than steel of the same thickness. To make synthetic silk, Carothers and his team had to mimic the way the molecules, the polymers, in natural silk were linked and structured. They used raw materials from nature, water and air, and from the mineral kingdom, coal, and later other carbon-based petroleum byproducts. Yes, nylon comes from crude oil. Then in the spring of 1934, Carothers suggested a different combination of molecules. You can actually see a pretty good version of what happened in that lab in 1934 by watching what's called the nylon rope trick. This one done for us in the chemistry labs at Iowa State University.
We make nylon polymers out of these two chemicals here. One is hexamethylene diamine, the other is sibacoyl chloride.
The names of the chemicals aren't as important in this story as how these two react when one, less dense, is poured on top of the other. Right where the two layers meet each other, right there, at what's called the interface, is where it happens. A chemical reaction that creates this, a material that can be pulled out in long, strong, stretchy strings that have a silky texture and shine.
This is the stuff, nylon.
Synthetic polymer chains made in carefully controlled conditions make perfectly uniform fine strands that can be woven into fabric that is lightweight but strong, difficult to tear or puncture. All properties that have made nylon the most used synthetic fiber in the U.S. after polyester, a descendant of nylon along with all polymer plastics.